Okay, these two have a couple of things you be careful of. This one right here, this has a -2 that needs to be factored out. Here's where a lot of people are going to make a mistake. They're going to miss that sign right there. If I factor out a -2, I've got to change that sign to a negative so that when I multiply this number times a -2, I end up with a positive. The other thing that's going to happen is, notice when I multiply this -2 that's on the outside that's been factored out times whatever number I put right there, that's going to give me a negative value. So since that number is going to be a negative, this number right here needs to be a positive. Okay, so be careful with that. Now I've got to, the next step is to complete the square. And I complete the square by taking half of 2. Half of 2 is 1, and squaring it. 1 squared is 1, so I'm going to put a 1 right there. And I'm going to put a 1 right there. The whole point of creating this and making it be a perfect square so I can write it in its factored form, and then of course I need to simplify this. The factored form of this is x minus 1, and then 3 plus 2 times 1, which is 2, so 3 plus 2 is 5. That means that my vertex is at 1, 5. Notice that I changed the sign, because see, here's the formula. Change the sign of h, that's what that says. The vertex is going to be at hk. So if you see minus, you write down a positive. If you see plus, you write down a negative for h. Change the sign of h, keep the sign of k. So the vertex is change the sign on the 1, keep the sign on the 5. So the vertex is at 1, 5. There's the vertex. Well, the other transformation, so this we said this was a shift. Sorry about the clap, but my lights were going out. This was a shift right 1 because h was positive. Shift up 5. And then the negative is a reflection. Reflect over the x-axis. And then the 2 causes a vertical stretch by 2. So, vertical stretch by a factor of 2. So since this has been, it's not opening up, it's opening down. Normally I would go over 1, down 1, over 1, down 1 on both sides. But instead I'm going to go over 1, down 2 because I'm going, my vertical moves are twice what they would be. On a normal quadratic I would go over 2, down 4, but this time I'm going to go over 2, down 8 because I'm doubling what I would normally do. Okay, and then try to, I'm going to check it in just a second when I go to Desmos. But that's a pretty good sketch. The axis of symmetry is right down the middle. The axis of symmetry is always going to be whatever your x value is your vertex. So your axis of symmetry, it's a vertical line, so it's crossing the x-axis, and it's crossing the x-axis of 1. Okay, so your axis of symmetry is x equals 1. Go over to Desmos. You type in your standard form equation, you type in the vertex form, and you see if they give you the same graph. Turn the blue one off. Turn the red one off, turn the red one on, turn the blue one on, and you see that they are the exact same graph. And what were those 2 points that we got? -1, -3. I believe that's what we had right here. -1, -3, there it is. And then the other one is at 3, -3. So I believe if we go over here to, here's 3, -3 right there. There it is. So there are all the points that we used to graph the quadratic on that other piece of paper. So they're the same graph. That means that we did it right.